Hello students, in this video we're going to be talking about the difference quotient. And the difference quotient is a very powerful concept. It's actually very much related to something in calculus. So for those of you that are interested in pursuing a STEM field, and you'll more than likely enter into some type of brief calculus or Calc 1 type course, you'll come across the difference quotient again, and it will actually be much more meaningful and powerful to you when you come across it. For right now, I hate to say this, but it's gonna somewhat feel like, what's the point of learning this? There's not gonna seem like there's a whole lot of meaning behind it, because again, I really think the application of the difference quotient comes into play once you are in your calculus course. But as you see here, there's a lot going on. I just kind of want to break it down. So instead of reading everything, if you want to read, just pause this video for a second and go ahead and read. But I want to make sure you're listening to what I'm sharing with you, because I'm going to really try to point out the important stuff here. So if you notice right here, I have m is equal to f of x sub 2 minus x sub 1 all over x sub 2 minus x sub 1. That should look familiar to you. It should look like the slope formula. It is basically saying y sub 2 minus y sub 1 over x2 minus x sub 1. We generally write it like this when we're thinking more about our applications problems and we're looking at the average rate of change. We've talked about that as well. But again, average rate of change is just another word for slope. So we know that we find the slope of a line. We said that, lines always have the same value of their slope across the entire line. There is an average rate of change. It is very consistent. Well, if you notice my graph here, the graph that is drawn is actually a curve. And so what we're trying to do here is identify the average rate of change from this point to this point, but it forms a curve, right? So we're trying to find the slope of this curve. So that kind of creates an issue here. And so if you look right here where I drew my star, we identify P as an arbitrary point on our function. And then we let Q be another point on our function. So we have some x and y variable, some other x and y variable. We're just representing that a little differently rather than just stating the value x and the value y. So what we're saying is that the average rate of change is the slope of the secant line. So the secant line is this pink line that's created when you connect point P and Q together. And we've talked about this as well. For those of you that have me in class, we've talked about it in class, and we've talked about it in some previous videos, that in order to find the average rate of change of a curve, you need 2 points, and that would create the secant line. But you could also do it with only 1 point, and only 1 point creates the tangent line. And a tangent line is a line that goes through 1 point on the curve. But because we're focused on average rate of change and we're trying to utilize 2 points, right now we're creating the secant line. And so that comes up with this particular formula right here, which is the difference quotient. And when I simplify, I'm left with f of x plus h minus f of x all divided by h. Okay? Now, you will not be required to memorize the difference quotient. It would be provided to you in future assignments, but you would just need to know how to use it and how to work with it. So I have an example here, and I provided the solution because I just want to talk through it. So we're going to use the difference quotient for this function f of x, but the thing that you need to realize is that you are just evaluating. Like, this is asking you to find f of x plus h, and then it wants you to subtract f of x, which you already know what f of x is because that's the function, and then you're being asked to divide by h. So the only challenging part here is really to find what is f of x plus h. So again, you're just evaluating a function. We know that f of x is equal to 3x minus 5. But now I want to evaluate x plus h. So that means every x in my original function is turning into x plus h, which is exactly what I did right here. And then I distribute in my 3, and I end up with 3x plus 3h minus 5. So now when I go to plug this into the difference quotient, I'm going to highlight things. I'm a color person, so I'm going to highlight this in orange here. 3x plus 3h minus 5. So my difference quotient says f of x plus h. Well, we just found that to be 3x plus 3h minus 5. And then in my formula, it says minus my f of x function. Well, we know that our f of x function is 3x minus 5. So I'm replacing 3x minus 5 here. And then divided by h. And all I have to do is distribute in this negative sign. So that gets me negative 3x plus 5. And then I can go and combine like terms. So 3x minus 3x, well, those actually cancel each other out. And then I have minus 5 and positive 5. And those actually cancel each other out. So then I'm left with 3h over h. But these are monomial terms with the h divided by h. So those cancel each other out. And I am left with 3. And what I want to make sure is not that you can just solve, but that you realize, what is this? This represents the value of the slope of your secant line. All right, so here's another example. Yes, I've provided the solution, but again, I believe I would encourage you to pause this video and try to solve this on your own before just, continuing watching the video for the solution. So I want to begin by finding f of x plus h, and I already know that f of x is equal to negative 2x squared plus 4x minus 1. But for every x that I see, I'm replacing it with x plus h. So this x became x plus h. This x became x plus h. And then I complete my algebra. I factor my x plus h. Notice that I had to FOIL to get this solution right here. X squared plus 2x h plus h squared. And I distributed my 4n into 4x plus 4h. And then I'm going to want to distribute my negative 2n to all terms. And when I get my final answer, there is nothing for me to combine. So this is a little nasty. But this entire thing represents my f of x plus h function. So when I go to my difference quotient, I take that entire thing I just found. I subtract it from my f of x function, which we said is negative 2x squared plus 4x minus 1. So I have that right there. And I'm going to need to make sure that I distribute that negative to every term inside of that trinomial, which you see I've done on my next step. So I have now a plus 2x squared minus 4x plus 1. I want to try to combine any like terms that I see. So let's see, I got a negative 2x squared and a positive 2x squared. Well, those are opposites, so they're going to cancel each other out. I have a positive 4x and a minus 4x. Those cancel each other out. I have a minus 1 and a positive 1, and those cancel each other out. And that looks like it. So now I have negative 4xh minus 2h squared plus 4h divided by h. I can take out a GCF of a h because I noticed this term has a h, this term has a h, and this term has a h. So I took out that GCF, and I'm left with negative 4x minus 2h plus 4. But because I have an h on top and bottom, I know that those just cancel each other out. And I am left with the final answer of negative 4x minus 2h plus 4. And again, this is your slope. Now, it doesn't seem very meaningful because you're probably wondering, like, what in the world is this h thing? Like, what's going on here? Well, again, this is when you get to calculus, you learn how to deal with that and make it more meaningful. But for right now, we're going to stop there because we have evaluated using our difference quotient. Okay? As always, I hope that you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out.